Hello and welcome back everyone. Topic for this video is to figure out the prime number within a given range, and that prime number should be printed. Two approaches would be looked at. First would be the naive or brute force approach, and the optimized approach that will be looked at how to get the prime number within a given range. Consider an example of figuring out prime numbers from range 1 to 60, and this will also discuss about the naive approach, where considered, or let's say all the numbers has been written till 60 and 1 is not considered a prime number, it will be discarded. Then moving on to the next number, here 2 is the smallest prime number, so that has to be printed out. 2. Then 3 is the smallest prime number followed by 2, as it has only two factors, 1 and the number itself, while 4 has two factors, 1, 2 and 4 itself. So there are three factors for 4, hence it is not a prime number. Then the number 5 will be checked, this will be generated. 6 will be checked, it will not be generated. And 11, 13, 17, 19, 23. So we are checking all the numbers from the range sequentially. And that is the idea of brute force approach. And so on. And the problem can also be to count the prime numbers within this range. Prime range taking two parameter L and U, with the precondition that L should always start with a value of 1, and then the loop is being executed, for which first the range is selected and it will start from 1 to U, and since 1 is not a prime number, it has to be jumped to the next number. So here total of 1 operation will be carried, and then the flag is set to 1, which is another variable, and this variable is to know whether that number is prime or not. If that number is prime, flag will have the value of 1, otherwise 0. And then from 2 to U, number has to be checked whether that given number is prime or not. Hence J will be starting from 2 to J less than I by 2. Why I by 2? Because 2 is the smallest prime number, and any multiple of 2 will be discarded, will be checked, but for that the flag value has to be turned to or set to 0, so that that number doesn't become a prime number. For that, this steps will be performed, where starting from 2 to U, and if that number is having factor more than 2, then for that the flag will be set to 0 and that number will not be a prime number. Now once that is obtained, whenever the flag value is set to 1, that element or that number has to be printed. This is the pseudocode. Let us get the time complexity for this approach. For first instruction, that is the for loop, starting from 1 to u, it will be executed for u times, and coming back to the sixth instruction, that is another for loop, it will be executed for u minus 1 time. Why? Because every time it will be checked, but based on the condition I by 2, only half of the elements will be checked, and remaining half may not be a prime number, hence it will be discarded. But let's say one wants to calculate the prime number between 1 to 7, and how many operations from instruction number 6 to 9 will be performed. Let's see that here one can see that 6 instructions will be performed, one for each of the instruction. Let's say the value if condition will be checked, so that will perform one instruction. For value or element 3, one instruction will be performed because that will be skip the if part. For instruction or for the value having 4, first it will be checked, so if condition is satisfying, and then 3 instructions will be checked, so that becomes total of 3 instructions will be executed here. And for 3 in the sense, here first instruction, second instruction, third instruction, so 3 instructions will be executed. For 5, one instruction will be executed. For 6, another 3 instruction will be executed. For 7, one instruction will be executed. So here one can see how many instructions are being executed. 3 plus 3, total of 10 instructions will be executed in this stage. And how many times outer loop will be working? It will be working for 7 times. Total of 70 instructions it will take to execute to get the number, whether that number is prime or not. Hence, this is an order of n square solution, where let's assume that u is set to n, where u can be a very large number. What further optimization can be made in this algorithm so that it becomes a slightly better version of this approach? So instead of starting from L equal to 1, let's start from I set to L plus 1, because 1 is not a prime number, and so these 3 instructions will be skipped or is not required. So we are making an optimization in this part, which is of order of 1 step, but this order of 1 step is optimized for u minus L plus 1 times, making it slightly more efficient, and then this has to be executed for the remaining elements. So instead of starting from 1, it will be starting from 2, it will be starting from 1 to I, and then the remaining steps will be same. This is still n square solution, but it is optimized in such a way that it is slightly better than the previous approach. So this is the optimized solution, but not efficient solution. Is there any way to make it more efficient? And that is done by using Sieve of Eratosthenes method and Eratosthenes method. This solution or this approach will be optimized and efficient as compared to this solution, brute force approach. So first let us understand what is the meaning of sieve. Sieve is generally something of this form where this is like a mesh of sizes and this is used to filter out filtering out impurities. So in this case the impurities is basically non-prime number, and that is the idea being used by the Eratosthenes, is to filter out the non-prime number from prime number. So this is the impurity. What happens is we are given a number, let's say 1, 2, 3 up to n. So here first a number of, let's say, 2 will be picked. So mesh size will be set that only elements which are multiples of 2 will be filtered out. So here the elements are multiple of 2, and so this becomes an impurity, which is basically non-prime number, and here 2 will be left out, remaining all will be filtered out. And then a size of the mesh would be increased in such a way that it takes the 3 as the input, and then the remaining multiples of 3 will be skipped. So here So here 2 and remaining multiples of 3 will be skipped, and this process is repeated for n times. So this is how it is going to work out. That is the idea of Sieve of Eratosthenes. Let's see. So let's see by an example where one needs to figure out prime number from, let's say, 1 to 50. So this will be, and let us represent this number in a tabular form. So let's say this is how it will be represented. This is just for the understanding purpose, but let's say this is written in by 10 cross 5. Or something of this sort: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Hence, this and 11, 21, 31, 41 until 50. Now, how will this work? So how does the algorithm work, Sieve of Eratosthenes? And so on till 20. So First it will consider the element 2 because 1 is already skipped. From 2 it will start and check. So whatever are multiples of 2 are there, it will be filtered out. So this will be filtered out, this will be filtered out, 8 will be filtered out, 10 will be filtered out, 12, 14, 16, 18, 20 and so on. So here becomes 2 and remaining are multiples of 2. Then it will move to the next number which is not marked. So this is not marked. So 3 will be next number. So this will be 3. And multiples of 3 will be skipped, filtered out. So 3, 6 is already filtered out. So leave it as it is. Then 9, 12 is filtered out. 15 will be filtered out. 18, which is already filtered out, and so on. So here multiple of 2, multiple of 3 will be filtered out. And so next is unmarked number is 5. So that is another prime number. 5 is another prime number. So 5 will be taken and all its multiple will be filtered out. So this will be filtered out. So 5, 10 which is marked, 15 marked, 20 marked, 25 will be next number. Then 30 is marked, 35 will be marked, 45 which is already filtered out. So this is the idea for the sieve of Eratosthenes. And so this is how the algorithm is going to work out. The next 7 will be selected. Then whatever unmarked will be there, then 11, 13 and so on. So in this way, all the prime numbers will be printed. Here is the pseudocode for the sieve of Eratosthenes. Considering it takes the parameter L and U, and first step is to take the numbers from 2 to U. Why? Because 1 is not considered a prime number, and the step that was considered optimized and in the brute force approach was to consider numbers from 2 to U. So that number has to be stored in an array, and then a flag variable is initialized, which is to check whether the number is prime or not. And as discussed in the last video, that I starting from U to 2 to I times, so one factor would be 2, another factor would be U by 2, third factor would be U by 3 and so on. So hence it will be executed till square root of U, and if the number is present in the array, means it's still present in the array, then we need to check whether that number has any multiples of that. If that number has multiples, then for each of the elements set the flag value to 0, and once that is done, in that way multiples of I is removed, and this will be executed for n by I, because each element will be checked from the ith element to U. Each element will be checked, and if there is a multiple, so here the condition is if I mod j mod I is equal to 0. So that means that number is prime number. Not a prime number, flag will be set to 0, and once that is done, print those number that is being finally present in the array. Hence all the prime numbers will be printed. and let us try to analyze the time complexity. Time complexity for this approach is big O of n log of log n, and in case anyone is interested to have the look of the proof, kindly check the link in the description. If case of query or feedback, kindly post in the comment box. Thanks for watching.